So first of all, thank you very much for the introduction. Thanks to all of you for coming. So before starting, you can check the slides. They are already online, so you can follow up on your mobile phone. Maybe it's going to be helpful while we will see some examples, or maybe you have questions, so it's just easier to go back and forward and check maybe things that are not clear enough. So I'm going to give you 10 seconds to scan this. So be quick. It's also in my Twitter account. So. Okay, so who is this guy in front of you? Hello everybody, I'm Luciano. I am a principal application engineer at Planet 9 here in Dublin. Whatever the title means, I think it looks cool in my CV. So, you maybe know me for some of my stuff, like I brought a book on Node.js. Actually, I'm a co-author of this book called Node.js Design Patterns. I also have a newsletter called Full Stack Bulletin. So if you are into the full stack space and you want to keep yourself up to date with the latest news or interesting articles, with this newsletter you can do it. Every week you will get 7 articles to read and a book, and yeah, lots of interesting stuff there. And also I'm doing this little project called Serverless Lab, that basically it's a training or workshop for companies to get started with serverless, especially on AWS and using Node.js. I am also online on Twitter, GitHub, LinkedIn, so feel free to connect with me if you want. So the talk that I will discuss today with you is based on some work that I've been doing in the last year and a half, and particularly it's something that started as 2 of the chapters that are in the book I mentioned before, where I start to explore some advanced patterns in Node.js. And then I also wrote an article for Rising Stack where I'm actually describing the solution that I will show you today during the talk. And those pieces of software that I used, they are available online and on GitHub, so you can even check the code. If you want to contribute, feel free to do it. I would be very happy. So the agenda for today, we're going to see what's the JWT specification, how it works, and then we are going to do some testing and exploring really to try to understand what are the benefits, how we can use them, how we can exploit them. And finally, we are going to try to brute force a token and see how that can be useful. So a JSON Web Token, which is the meaning of JWT, is a compact, URL-safe means of representing claims to be transferred between 2 parties. The claims in a JWT are encoded as a JSON object and blah, blah, blah. I am already bored. So this is the RFC specification. If you really want to read the standard, that's the place where you can find it, but I guess it's going to be a bit boring. So I'm going to try to make it a bit more interesting. So this is a JWT token. Okay, I don't think it's helpful. So I'm going to try to make it even more simpler. So my definition of JWT is a URL-safe, stateless protocol for transferring claims. And again, maybe still not helpful, because what does it mean URL-safe? What does it mean stateless? What does it mean claims? I'm going to explain all those different parts to you. So URL-safe basically means that a token is a string, and you can put this string safely in a URL, which means that this string is never going to contain characters like equal, slash, hashtag, question mark, and all the others characters that can be parts of a URL. So for example, you can use the JWT token as a part of a query string parameter, and you don't need to encode it. So it's very easy to use it with URLs. Stateless. So when you have a JWT token, you can easily validate the token. So see if the token is still valid in time, or if it's authentic, or if it was generated by an authority that you can trust, without having to query a third-party database. So sometimes this property is also called self-contained, and we will see in a moment what that really means. Then I said that is a way to transfer claims. So what is a claim? A claim is some certified information that you want to transfer between parties, between services. And for example, it can be identity. So for example, if you are using the token to identify a login, you can use a claim to say this login is for a specific user. Or maybe you can use it to create an API key, so you can embed in the token information that are relevant for an API key. Or for example, you can create ownership, so you can combine different things. Like you can say, with this token, I'm saying that a specific person is authorized to go into a concert. So it's like a ticket, right? And there are also other important things that you can use as part of the claim set. For example, you can express time constraints. You can say this token is valid from this moment and until this other moment. You can express something like audience, which means this token is only valid for this specific audience. Can be a user for a specific mobile app. And then you can also identify an issuer authority. For example, this token was generated by this server. And also, as part of the claim set, you have different protocol information. So the type of token, the algorithm used for the signature, we will see all of this better in a moment. So in general, when we talk about claim, is all the information that is stored directly inside the token. Again, this is a token. Let's try to understand how is it made. What are the different parts? So you might have noticed that there were two dots, and that's because generic JWT token is divided in three parts, and they are separated by a dot. What are those three parts? The first part is a header, the second part is called the payload, and the third part is the signature. So header and payload are base64 URL encoded. I don't know if you notice here, if you ever use base64 as a way to encode, I don't know, maybe binary data and make it more readable, you will see that the character set is very similar there. So it's very easy to figure out that there is some base64 encoding there. So let's try to decode, especially the header and the payload. So when we try to decode the header, that's what we get. When we try to decode the payload, that's what we get as well. So the data is JSON. And you will start to understand why I said before that the token is stateless or self-contained, because there is data inside that you can read without having to query a third-party authority. So let's see what the header really contains. It contains two fields. The first one is type, and it's always JWT. And the second one is ALG, which stands for algorithm, and it identifies the algorithm that is used for the signature. The two most famous algorithms are HS256, which is basically asynchronous hashing, and then we have an asynchronous hashing with public and private key, which RS256. And then there is another one, which is a bit infamous, because it was part of a big vulnerability, I think 1.5 years ago. And if you want to read the full story, there is a link there. But basically, you can say this token has no signature, so you could add tokens by just recreating the token without signatures. And many systems were vulnerable to this thing. So the payload, in this case, I had message and load Dublin as a payload, can be basically anything that you want to express as a, you can express it as a JSON, but basically anything you want to put inside the token. There are a set of suggested claims that are called also registered or standard. And for example, you might have issuer, in this case Auth0, you might have a subject, which is the person or the system for which you created the token, and can be an email or an ID in your system. Then you can have an audience ID, which might be a URL or the ID of an application. And then you can have things like expiration time, don't use before a specific timestamp, or the timestamp when the token was generated. And of course, if you want to represent them, you will see them as a JSON inside the JWT token. So far we just said, okay, there is a token, it's a string, somehow it's encoded. We have seen it's three parts, there are dots to separate the different parts. It's base64 URL encoded, but it's just metadata. Why we should trust the data that is in that string? What does it make it safe? And what makes it safe is the signature. And the signature, again, it's a string generated, encoded with base64 URL algorithm. And basically, the signature is built by encrypting, creating a cryptographic signature of the header and the payload, which looks more or less like this. So we have an header, we have a payload, and then we can combine the two of them together with a password, and that will give us the signature. So in reality, there is an element that is sometimes called password or secret. That's what makes it reliable. So if a system, if you are passing this token to a third-party system, and this system knows the secret, it will be able to tell, okay, this token is actually authentic or not, right? So the secret is one of the most important parts of this token, and you should never disclose it with third parties that are not allowed to verify the token or to generate new tokens. There is a website called jwt.io, which is a playground. So if you want to experiment with JWTs, you can easily create or visualize existing tokens, edit them, verify if the signature is correct, and we will use it in a moment in our demo. So I want to show you an example first to make you really understand why JWT tokens are useful and how they compare with more traditional approaches. And one of the most common examples is session. So I will show you first how to do a classic implementation of a session on a website, and it's based on a cookie or a session database. So in general, when you implement a system with a login and you will use this approach, you will have three systems. You will have a browser for the user, then you will have a web server, and then you will have a session database. So at some point, the user wants to log in, and is going to send a post request to his browser, sending the username and the password. The server receives this data, verifies that the username and password are correct for this user, and it creates a session. The session is just a random string that gets saved in a database together with the username. And basically means, okay, whenever somebody is presenting me this string again, I'm going to know this user is Luciano that authenticated at this time. So this string is saved in a database. And then it's sent back to the browser as in general as a cookie. Can be a header, can be anything else, but the idea is that the browser from that moment on is going to send the string back to the server to identify itself. So the next request can be, for example, okay, now that I am logged in, give me the profile page. And you will see that the cookie is sent back with that string. The server receives this request, but it doesn't know anything about the session, so it needs to query the database to get the username, and then once the server has that information, it can successfully render the page. So you will see that there are those three entities, and the message needs to go across all of them to be able to render the page for the specific user. When we use JWT, the implementation is slightly different. And in reality, we only need two parts, the browser and the server. We don't need a database. So again, the user logs in, sends username and password. This time the server verifies if the username and password are correct, but instead of going to a database and creating a string, it can just create a token. And the token will be created for the user Luciano, and there will be a specific signature that will be created with a secret that only the server knows. So the token is going to be returned to the user. It can be a header. In general, it's if you do it through JSON, it's going to be inside a JSON, and then the browser will use it as a header. But the idea is that inside this token, as part of the claims, you will have the subject, which is Luciano. So the next time that the browser is going to do a request, for example, it's requesting the profile again, it will embed in the request the token again. So the server will receive the token, and without having to go into a session database, it will just take the token, decode it, see that the subject is Luciano, and then the only thing that has to check is this token valid? Because if it is valid, I can just assume the user is really Luciano. I don't need to go anywhere else to verify this information. So assuming that the signature is okay, the server can generate the page for the specific user. So just to compare again those two approaches. When you are doing a classic cookie session implementation, you need a database to store the session data. And then every time you receive a request with somebody sending you a session, the server needs to query the database to really see the relationship between the string identifying the session and the user to which the session is associated. And basically a session is just a random string to which you can attach metadata that will live in the database. So in the session token itself, there is no data attached. And there is a very important difference between the two approaches, and we will see this better at the end, is that the session built this way can be invalidated at any moment. Because you have a session database, you are in control of that data, so anytime, if you are worried that that session might have been compromised, you can just say in your database, okay, next time, consider this session as not valid anymore. JWT instead, you don't need a session database, that's why it's called stateless. And all the session data, so for example, the username or the roles that this user has are inside the token. And every time is the browser sending all this data back to the server. So every time the server receives this data, it just needs to verify if the data is signed correctly. And all the metadata will be inside the token, so you don't need to go into a database to verify that. The issue is that if somebody is forging the token and you know that, you have no way to invalidate the token because there is no shared database, unless you have to build some list of invalidated tokens, like a blacklist. But by default, you have no way to do that. So, okay, it looks great because you don't need a database, the implementation looks simpler, and probably it's going to be even faster because you have less messages going around different systems. But of course, it's not only gold what shines, there are pitfalls, and let's see what are the most important issues or problems or things that you might have to worry. So the first thing is that the data is public, which basically means that if you have a token because you logged in a system, you can read all the claims for your token. And of course, there shouldn't be sensible data inside it. So if you are creating a token from a server, you shouldn't embed the password, for example, of the user there, or other sensible informations. So the idea is that, okay, I logged into a system, I can see in the browser the token, I can read everything that's stored inside the token. So that might be an issue. And then since there is no token database, maybe if I can forge a token, the next time I will make the request, the servers will not be able to tell the difference between a token that was actually generated by the server or a token that was generated by somebody else. So I'm going to show you a little demo before moving on. So I created this little web application, like it's super simple. The only thing we can do is just log in. So I'm going to try to log in. Actually, let's make it a little bit bigger. So I'm just going to send username and password, and then I'm logged in. And I'm logged in as a regular user. So I cannot do really much here because this application is only for admins. And one thing that I want to show you here is that in the URL, I don't know if you can read that, but we have a parameter called SIT, which is our session token, which is a JWT token. So I'm going to copy this and save it here, because we are going to use it again later. But also I want to show you what's inside this token. I mentioned before that there is this website called jwt.io that you can use to test JWT tokens. So if I add my token here, we will see that the token is using this specific algorithm, and this is the content, the payload of our token. So the subject is Luciano, the role is user, and the token was generated at this specific timestamp. So one thing to notice is that with this tool you can also verify a token, and at the moment by default it's trying to verify the token using the secret, so the string secret, and this is not the right secret used by the application. So at the moment I have no way to change this token, but anyway I'm going to try to do something. I'm going to try to change this role into admin, and you see that the token has changed. And what happens inside the application is that it's going to use the secret string to sign this new token. So I'm going to try to use this new token that says that I am an admin in my application. So if I go back here and basically I just replace the string here, it tells me, okay, this is an invalid session token. Why is this happening? Because I don't know yet what's the secret, what's the real string that I have to use here that is the same used by the web application that makes the token valid. And for example, if I change this string to X, Y, Z, for example, every time I change something, I'm going to obtain a new token because the signature here will be different. So we are going to see how we can use this information to exploit the little web application that we have here. So what's the idea? We are using this token, this JWT token that is created with a symmetric signature. And the idea is that if we can guess the password, then basically we can regenerate the token and change all the information inside it. So the complexity is literally, okay, how do we guess this password? And how difficult can it be to guess a password? And the idea is that the way that always works is that you can create a brute force attack using, I don't know, some distributed techniques. And maybe if you are lucky enough or if you have enough compute power, you will get at some point the right password. And we want to do that in the second part of this talk. And before showing you how this works, I'm going to show you a working example. So this was our token, our valid token, the first time we did the login. And we want to use this token to basically discover what's the password used to sign this token. I have created here a little application, and I'm going to explain you how to build it later on, that is composed by a client and a server. So first of all, I'm going to show you how the server looks like. So basically, it's a command line application that you can run, and the idea is that you can run it and say, okay, start a server that will crack this specific token. And you can also specify an alphabet, but we will see later on what that means. For now, just bear with me. I'm just going to start this with a given token, but I want to use a shorter alphabet just because it's going to be quicker to find the solution. And I want to use only lowercase characters. So I'm just going to copy this one here, and then I need to add the token from here again. So this is going to start my server, and it's listening for clients to connect. Now I'm going to connect 4 clients in parallel by just running JWT cracker client. And you will see here that what's happening is that the server is trying to coordinate this brute force attack. So we have 4 clients running in parallel, and they are trying to explore different strings until one of them will be able to find the solution. So going back to the presentation, I'm going to explain you how I built this proof of concept to do distributed JWT crack attack. So the idea is that if you have a valid JWT token, you can try to guess the secret, and then given a string that you are using as a guess, you can validate the token against that string. So you are trying to rebuild the signature using that string. And if it matches the original one, then you found the secret. And of course, as soon as you find the secret, then you have the power to change the content of the token. So you can claim you are an admin, or you can change other things that might be relevant for the JWT token in that application. So the magic weapons we are going to use to do this experiment are Node.js, ZeroMQ, and JSON Web Token module. For those who don't know what ZeroMQ is, it's an open source embeddable networking library. Also concurrency framework. So basically it's a C library, so you can use it with many languages or even embedded in, I don't know, hardware if you want, to create messaging patterns between different networking systems. So in our case, we use it to coordinate the messaging between the client and the server. But before we're going to check some code, I want to explain better what's the idea, how this specific client server is implemented. And the idea is that the brute force problem, it's a virtually infinite problem because you have a virtually infinite solution space, right? It's virtually infinite because your string, your password is going to be limited. You're going to be a certain amount of characters. So at some point you are going to explore the full space, but you can have arbitrarily long strings. So it might get complex and complex the more it gets bigger, the string. So, for example, if your space is made by the letters A, B, C, and 1, you can create all those strings, and it can go on and on endlessly. And the important thing is that we can create a relationship, a bidirectional relationship between the space of integer, positive integers, and all the strings over a specific alphabet. As soon as you establish an order inside the alphabet that you're using. For example, if we have an alphabet that is A and B, we can say, okay, we can map 0 to an empty string. We can map 1 to A, 2 to B, 3 to AA, and so on and so forth. And you get the idea that this way you can list all the possible strings over this alphabet. So we want to build this distributed architecture. We want to have a server and a number of clients. The server goal is just to initialize, let's say, a state using a valid JWT token and an alphabet. And then the only goal is to coordinate the exploring this space through the different clients. So the idea is that we will see better in a minute, but the server only knows about the token and the alphabet, and then it tries to delegate to the clients the role of trying the different password and see if the password match with the JWT token. So the role of the client is actually to verify if given a string and a token, that string is actually the solution for that token. So what are the networking patterns that we are going to use? In ZeroMQ we have a different number of possibilities, and the possibility that I really liked for this specific problem is called the router-dealer pattern, because it's basically a request-response type of patterns. So you have a server and the server can receive a message, and then you cannot receive any other message from that specific client until you respond. So all the time is like, okay, you are telling me something and you are waiting for a response, and only when you get the response you can tell me something again. So it's this kind of synchronous communication between the server and every single client. And this is very useful, and we will see exactly how, because the idea is that a server is creating jobs for a client and then it's waiting for the client to complete the job before you can send another job back again. And of course we have another type of message, which is basically the termination message. So as soon as a client will find the password, you might have thousands of clients connected and you want to terminate them, saying, okay, somebody else found the password. So for that we're going to use the publish-subscribe model, and basically we will have two channels. One is the router-dealer channel and one is the publish-subscribe channel. One to delegate the task and another one to just say, okay, somebody found the password, so stop the execution. So in order to understand how the server coordinates the different attack, we can see how the state is designed. But the main idea is that we have this space, we can map the space of strings over an alphabet to integers. So the idea is that you can split the space of integers into chunks and then tell to the different clients, okay, for now explore this specific range. Another client will explore another range, and then you will keep moving forward until you can find the solution. So this is the idea. This can be a representation of the initial state of the server. You have a cursor that is starting from 0 and an array of connected clients. At some point, a client will connect, so you can start to delegate some task. And the task is going to be, okay, I'm going to give you to explore the space that goes from the number 0 to the number 2 over a specific alphabet. And here we are, of course, assuming that the chunk's dimension is 3. So as soon as we have other clients, we are going to allocate other space of the possible solution to the connected client. So we are going to allocate 0 to 2 to the first client, 3 to 5 to the second client, and 6 to 8 to the third client. Of course, at some point, one of the clients will finish to explore that specific space, and assuming the password was not found there, is going to ask for another chunk. So at that point, for example, the client 2 will get the next piece of space that needs to be explored. And this will go on forever until one of the clients will find the solution. So let's analyze some code. How can we build this state that I just described? So the idea is that in the server we said we have to start with an initial state, which is a cursor and an empty map. And then we have two utility functions, and the first one allows us to assign a batch to a client, and the second one will allow us to register a new client. I'm not going to go into the details, but the idea is that you basically have to always increment the cursor and keep track of all the state inside every single client. And the next time a client is going to ask for something, you can move the cursor forward. So this is again a better visualization of this idea. The server is waiting for a client to join. When the client joins, it's going to respond with a start message. And inside the start message, we have the current token, the current alphabet, and then the first batch. So for example, it's going to be 0 to 3 in the example we saw before. At this point, the client is initialized because it knows what's the token that we are trying to crack, what's the alphabet that we want to use to search for a password, and what's the space that it needs to explore in this specific moment. And when the client finishes to explore this specific space, can ask for the next batch. And the server, of course, will respond with the new batch. And this flow, 3 and 4, can go on forever until somebody will find the password. At that point, there will be a message called success that will communicate the secret to the server, and the server then can dispatch the secret to all the connected clients. So this is the implementation of this logic. We have a router that is initialized using the ZeroMQ library, even though I'm not going to go in this detail. But the idea is that every time we pass a message between server and client, this is a JSON message, and we can use the type, for example, join, next, and success to do all these actions I described. Again, I'm not going to go in details, you can check this in your own time. Important things are that we have this socket called batch socket that is actually a ZeroMQ socket, and that's the one used to dispatch and receive the messages. On the client side, again, there is a very similar structure, so we can receive a message and we can decode this message and see if it's a start type of message or a batch type of message, and based on that we can do things. And we can have a function called process batch, which is not implemented here, and we will see later on, where actually the core of verifying a JWT token will be written. So here we are just dealing with the messaging logic. Okay, so then before checking the code to verify a token, how this code can work. So we say that every client receives a specific range. So a batch is a range from 3 to 6 in this example. And the client already knows what's the alphabet because the first time it joined the server, it received was the current token and the current alphabet. In this example, we have as alphabet A and B. So which means that as soon as it receives 3 to 6, it will know that the solutions to check are AA, AB, BA, and BB. So it's going to start to check all of those in order, and then if one of those actually matches the signature, then we found the solution. So the code looks more or less like this. We have a utility function that is called indexed string variation, which is basically a library that allows us to map integers to strings over a specific alphabet. And then basically we'll say, okay, I know I have to start from a variable called from and reach a variable called to. So I'm going to create a for loop from to, and then I will use this index to get the current string, and I'm going to assume this is the valid password. So I'm going to call it password. And then I'm going to run this function called JWT verify that is coming from the JWT library that I mentioned before. And this function is going to basically throw an exception if this token is not valid against this password. So if we move to the next instruction, basically we found the password. So we can just say, okay, the password is found. Otherwise, we can just catch the exception, but we don't need to do much because we just want to keep looping. So we just ignore the exception this way. And this will go on until we explore the full batch. At that point, the rest of the code is going to ask for a new batch. So going back to our demo, I expect, if we were lucky, that we have the password at this stage. Yes. So here we have the password, it's Joyce. So now we can go back to our jwt.io and use the secret Joyce. Then if we change something, it's going to regenerate the signature. So this one is actually a valid token with the password Joyce. And now we changed the role from user to admin. So now I'm going to expect that if I go back here and use this new token, yes, we are in. We are now an admin, so we can do powerful things. Yeah. Okay, so let's try to close it off. The first question that you might have is, okay, you show me in, I don't know, 25 minutes how to crack a JWT token. So is JWT safe to use? And of course it is. And there are a lot of big companies that are relying heavily on JWT, like Auth0 or even AWS inside their service Cognito, and OpenID, which is the one used also by Facebook, and GitHub relies heavily on JWT tokens. So it is safe to use. But, of course, you need to use it wisely, which means that you have to use a strong password, which most of the time is a long enough password, and then you need to store those passwords in a safe space. There is an even better solution, which is actually the one used by Cognito, that is not to use the synchronous algorithm to sign, but to use the asynchronous one. So you are going to have a public and private key, and the server is always going to sign the tokens with the private key that only the server will know, and then everybody else will be able to verify the token with the public key. But nobody will be able to generate a new token if you don't know the private key. So that's actually a stronger implementation of JWT, and I really recommend, if you want to use this in a server, to use this approach. Even though, for example, if you explore Auth0 there, by default they use the synchronous encryption, the synchronous signature. Okay, then I got this question last time I delivered this talk, which was very interesting, and probably it's important to explore better what it means. So one guy asked me, what if I create a token that is short-lived? What if I create a token that only lasts, let's say, for 15 minutes? Maybe this is a banking application, so 15 minutes is all right. Then is this safer than any other token? And the response is no, because JWT is stateless, and actually the expiry time, most of the time is, well, it's always stored inside the token itself. So if you are able to crack a token, you can change the expiry time as well. So even if you have a token that was generated 2 years ago, if the password is still the same, you can crack that token, so you can find the password for that token, and using that password you can change any other token and regenerate tokens even that looks like they were generated 2 minutes ago. So it's very important to understand that JWT is stateless, so you don't really have ways to protect against this. As soon as somebody creates a fake token, you have no way to tell that the token is fake, and they can change any data. So you have to prevent this kind of attack. Then the next question would be, should I be worried about brute force? Well, my general answer would be no, because brute force is the last kind of attack that an attacker can do. So in general, when an attacker doesn't know anything else, he's going to try brute force. So if you know how to protect against all the other attacks, and you know how to protect in general against brute force, so use strong password, don't use common password, use long enough password with special characters, then you don't really need to worry about that. Then, just to recap everything we saw today, I think that JWT is a cool and stateless way to transfer claims, and the things that you need to be aware is to choose the right algorithm. So most of the time we'll suggest you to use the asynchronous signature, and if you want to use the synchronous one, you need to make sure you are choosing a good password and that you are sharing it only with the services that needs to validate the token. And then you don't have to disclose sensible information inside the token, like you will never store the password of a user inside that, because everybody can just read that and it will be a plain JSON. And then, of course, don't be too much worried about brute force, but try to understand how a brute force attack works so that you can protect yourself against that. Also, I think as part of this talk, you understood that you can easily create with Node.js application like client servers to do distributed attacks or distributed computation in general. And probably you can use the proof of concept I created as an example to do that. So that's basically all.